Matrix, and welcome to another exciting episode of Woza Matrix. Today we are assisting you with your exam guide for Physical Sciences, Paper 2. My name is Luni, and I'm here to assist you to get all of your questions and comments through to us. So don't forget to hit us up on our social media pages, search for Woza Matrix, as well as our WhatsApp line. I'll leave all the details for you on the screen. We've got an exciting competition coming up, guys, so do stay tuned for all of those details. As always, I'm not alone. With me are my sign language interpreter, Nicolene, as well as my awesome teacher, Temba. Thank you so much, guys, and take it away.
Thank you very much, Luni, for having me. Welcome, Matrix, to today's session. We are focusing on paper 2, which is the chemistry. Right. There is quite a lot, that goes on as far as the exam prep. We have entered, the most crucial stage of our preparation leading to the final exam. So whatever we discuss here, it's part of what could be, what is actually essential, even though we may not have the opportunity to actually touch each and every aspect of our curriculum. But we'll just do a snapshot here and there, look at, a specific problem area based on, the performance of, the grade 12s in the previous year, and then advise in terms of, what is it that we can do better in terms of the strategies. Right. So this is our chemistry paper 2. What does the paper look like? Okay, it's 3 hours. Okay, it's 150 marks. 2 sections, section A and B, with the section A carrying a total of 20 marks. All right. So if that is 20 marks, we are saying that that's the multiple choice. Okay. So the multiple choice is 20 marks. Okay. Right. So the 20 marks, it's something that you need to carefully manage, because the multiple choice covers all the sections. So what that essentially means is that we need to allocate adequate time, be it at the beginning or at the end of the 3 hours, because 20 marks, very few questions in section B have actually more than 20 marks. So it says you need to allocate a decent amount of time for the multiple choice. And then section B is 130, okay? So you add that, it will give you a total of 150, right? So section B covers all the sections, all right, or all the topics, okay? And then the 10 questions are of different levels. Not all the multiple choice questions are about what you know or you don't know. In some cases, it's not just about remembering. It has a lot to do with the application, the conceptual understanding, the analysis, a wide range of skills are actually examined in as far as the multiple choice is concerned. Okay, right. Moving along, we've spoken about that. Now, if you look at the chemistry paper, a greater proportion of it is actually based on chemical change. And under chemical change, there is a number of topics. You can mention your rates of reaction, your chemical equilibrium, your electrochemistry, the list goes on. Now, which says to us the chemical change carries a weight of 84 marks. This is more than 50% of the total marks in the chemistry paper. And then chemical systems, here we're actually talking about fertilizers, okay? And in my opinion, these are some of the easy marks that you need to pick up. So, but look at the comparison there, 84-18. It means a lot of emphasis is on topics on, chemical change. And then we've got organic chemistry under matter and materials, which is just 45 marks. All right, okay? And then let's look at the tips in as far as how you approach the chemistry paper, how you actually, strategize, and so that you maximize your performance. Because, anxiety is a natural, component of an exam. If something really matters to you, you'll be stressed about it. The adrenaline levels will be high. That's only normal. But let's look at some of the, strategies to try and ease that strain that goes with the stress of the examination. Guys, you need to plan your time for reading time. This reading time is actually 10 minutes, okay? So before the onset of the exam, what actually happens, the examiner will issue out the exam material, so then there is that 10 minutes reading time. management of that 10 minutes is very important, okay? Scan through the paper, okay? Identify the questions that are actually easier for you. Now, once you have done that, you know that you do not have to start with question 1, okay? You can start with the questions that are actually, you can get the most marks out of, so that you can also enhance your confidence levels, okay? So you need to allocate adequate time for each question. What exactly do we mean? Let's break it down. We are saying that, let's say a question, for argument's sake, is 20 marks, okay? Now, you cannot obtain 20 marks in less than 5 minutes, okay? So logic says, the weight of a particular question has an implication on the amount of time that you actually need to allocate for it, okay? So if it's 20 marks, you need at least, or a minimum of 20 minutes. That's how the exam has been structured. Okay, now there'll be cases where you get stuck, which is natural. Okay, do not spend a lot of time trying to struggle to answer that question by all means. When time is up for that question, which is 20 marks, now you are moving to 25. Just move on. You'll come back at a later stage. That's one of the things that actually you do to relieve that strain, because the moment you are left with limited time, even the stuff that you actually know, you'll tend to make a lot of careless mistakes because of the time constraints that come with that. Okay, right. And then the prior knowledge, okay, this is the stuff that we would have covered, in grade 10 and 11. Take for example, the stoichiometry is a big issue, in the chemistry paper. It's something that could be examined from question 1 until the last question, whatever the case may be. And then it says to us that we need to be well-grounded. Let's go back and revise the mole concept. But this is just an example. Now, you'd use the chemical formula, okay? This is the periodic table, polyatomic ions. These, for example, when you talk about the ammonium ion, just know the formula of the ammonium ion. This will, as an example, come in, let's say, under fertilizers. So these common ions, you'd have covered all this stuff in chemical formula in grade 10. So always remember that, okay? And then the balancing, which is the law of conservation of mass. In most questions on chemical change, electrochemistry, fertilizers, there's quite a lot that goes on in terms of the reactions. So chemical change involves formation of new substances, and there's no better word to describe that than a chemical reaction. So by all means, it becomes the imperative that we revise chemical formula, because when you balance, we use, consequently, the stoichiometric ratio in which substances react with each other. So if that formula is not correct, so it has implications on, the stoichiometric calculations that would carry out subsequent to that. Okay, right. So also understand the difference between physical and chemical change. That's grade 10 stuff. Then intermolecular forces, as far as physical properties of, organic compounds under matter and materials. And then the energy changes is another critical component. So this stuff actually comes from grade 10 and 11, okay? Right, and then the mole is the big thing in chemistry, okay? There is no way we can talk chemistry without the mole. And in often cases, the learners tend to mess up everything else because all these concepts are based on the mole concept. Right. Now, remember, by definition, you would know that a mole is the SI unit of quantity of matter. We don't talk grams, kgs, tons when we talk chemical change. We actually refer to the mole because a mole of any substance contains the same number of particles. Okay? So understand the mole in terms of N is equals to M over capital letter M. This is a very important formula. There is no way that you can write a chemistry exam without actually talking about the mole, okay? Remember stuff from limiting reagents from grade 11, percentage yield, empirical formula, the list goes on, okay? But what is also very, very crucial as far as stoichiometry, it can be in any question, from organic chemistry until fertilizers and everything in between. So the mole is just the chemistry, okay? Right. Let's move on. And then, obviously, if you remember very well, the experiments that we do are also an integral part of our exam. be it formal or just recommended. The scientific skills in terms of scientific inquiry, your observations, identifying the apparatus. So just touch base with that. Make sure that you sorted with that. Make sure that you also understand the different types of variables involved in experiments. Be able to identify, say for argument's sake, we'll talk about reaction kinetics or rates of reaction. We know there are 5 factors. A question may come based on how concentration affects how quickly a reaction takes place. So the variables there is concentration versus reaction rate. Then we keep everything else the same. So that, general idea says to us that we understand the key aspects of an experiment, and because the scientific process is what science is all about, So we need to also revisit that as part of our preparation. Okay, right. And then data are obtained from experiments may be given to us. Then this takes us to the graphs. So you must make sure that you also understand the difference between plotting and sketching. Now, even with the physics, it's still very much applicable. If you're given a set of values or results or data that has been obtained from an experiment or an investigation, you need to understand that when you use that data, let's say in a grid or using an appropriate scale, what will actually happen? You are plotting. But the sketch just gives us, like in rate of reaction versus time. You can talk about the relationship that exists between time and rate of reaction as a particular or a specific type of a reaction occurs. Okay? So interpretation, very important. Now, in this case, you are given a graph, and then you must use the graph to answer questions. Now, what the examiner would emphasize is that you need to use the information from the graph. So every information would extract it from the graph itself. Okay? Right. Okay? Say, for argument's sake, you've got, let's say you have got volume of gas. Okay? Let's say the volume of gas is in let's say is in cubic centimeters. Okay? Is in cubic centimeters versus time. Okay? And then we've got a curve of that sort. Now, this is a graph that you are given, usually in reaction kinetics. Understand the key components. So this is volume versus time. Okay, so this is time, let's say in minutes. It could be anything, that's volume. So interpretation is based on your understanding of the information that we extract from the graph. We could be calculating average rate of reaction. You could be calculating, the rate of change. It could be anything. So graphical skills as, application of mathematics in science is a very key component of our topic. Okay. Now you also need to use the examination guidelines. This has a lot to do with definitions. Okay. So definitions are actually derived from the examination guideline. Keywords must be used in the correct context. And remember, it's 2 out of 2 or 0 out of 2 if you're asked to define. But questions on definitions, sometimes you may be given a statement and you are required to identify a term for that description. So it could work both ways. It can be from a term to a description or description to a term. So we need to exercise that flexibility. All right? Okay, so the exam guideline will be our checklist. Ask yourself, do I know what is a homologous series? What is a functional group? So I tick those that I cannot remember, because definitions are based on recall. You need to revisit the document. All right, okay, the data sheet, which is the equations, the formulae, the periodic table, in terms of, the groups, the charge, the oxidation numbers, ultimately, even the standard reduction potential table. These are the tools that we need to familiarize ourselves with, without which, that's why we continue to make a lot of mistakes. So as part of our preparation, it's important that we are familiar with the data sheet. And it's no secret, the data sheet is always given in an exam. So there's no need whatsoever for you to memorize every piece of it, for the purpose of using it in the exam, because ultimately it shall be provided to you. Okay? Right. And then in terms of the multiple choice, it's important that we have to allocate enough time for us to actually answer multiple choice, because that's 20 marks. So you need a minimum of 20 minutes, if not more, for you to respond to those multiple choice. But the other thing about multiple choice, you just don't focus on the options that you think they're incorrect. Look at those that you think they're totally out and think about a reason why they are incorrect, because there's a lot of thinking in science. And then, while given the 4 options, try and eliminate the distractors. So the distractors are essentially those that are totally out, okay? Right, and then also, you need to pay careful attention to the keywords in the question. In some cases, it will be written in uppercase or bold, okay? Because there's always a catch in the question. So emphasis is on words or terms that have been written differently, okay? So once you respond to the multiple choice, read the question once again and check if you have answered the question, okay? Because a lot happens in your head, while you're trying to think about the reason why option A is out or whatsoever. Then as a result of that, you end up not answering the question, right? And then there's a simple example here. Which one of the following statements best describe a state of dynamic equilibrium? So let's identify the concept involved. This is about equilibrium, okay? And once we talk about equilibrium, we know there are 3 factors that affect equilibrium, okay? So it should be about equilibrium, okay? Now, A says the limiting reagent has been used up. We don't talk use up when we talk equilibrium, so we eliminate. Okay, the forward and reverse reaction have stopped. When we say something is dynamic, it cannot stop. We eliminate that. So now we are left with 2 of the 4 options. We have a 50% chance of getting it right. Now, deciding as to which of the 2 options is correct, it actually enhances your chances of getting it correct. Lonnie, we'll continue after the short break. Over to you.
Thank you so much, Themba. Guys, we are going to take a quick break, so don't go anywhere. We'll see you straight after this. Welcome back from the break, Matrix. Thank you so much for tuning in. If you've just joined us, we are assisting you with the exam guide to help you prep for the upcoming exam. Well, some exciting news, guys. Woza Matrix is bringing you the hashtag WozaWinner competition, where 2 lucky matriculants stand a chance to win 2 gigs of data. So see the screen for the details, as well as our Facebook page, and enter the competition, guys. Well, enough talking from my side. Over to Themba.
Thank you, Lonnie. We're now going to focus our attention on a specific area, as an example, and this is going to be based on electrochemistry. Right. Now, in my opinion, I hope you also are of the same view. Electrochemistry forms one of the aspects of the chemistry paper that contains a lot of easy marks. Easy marks in the sense that it has to do with your remembering, and your understanding at a very basic level. Okay, let's look at the tips that are involved in electrochemistry, right? First things first, you need to identify, in the case that you are given a structure of an electrochemical cell, decide whether the cell is a voltaic or an electrolytic cell. In other words, guys, remember that sometimes we would refer to the voltaic cell as the galvanic cell, because the 2 terms can be used interchangeably to refer to the same type of an electrochemical cell, okay? So this has to do with the structural differences that we must know between a galvanic and an electrolytic cell. So these are the components that make up, each one of those. So we need to revise that as well. Go back and check, okay, what are some of the features that are common, okay? But beyond the differences, there are also similarities in the sense of, the processes that take place in both electrochemical cells, whether be it voltaic or electrolytic. The transfer of electrons does take place. We still have an anode and a cathode. So we need to compare and contrast in our understanding between the 2 electrochemical cells, okay? We also need to identify, okay? We've spoken about the differences as well as the similarities, okay? Right. Now, as a way of maybe, trying to create a concept map to assist you in terms of remembering, remember there are the broad category is electrochemistry, two types of cells. So this type of a summary, we can tabulate differences and similarities. Will go a long way in terms of assisting you to remember during the examination. All right, now moving along with the tips on electrochemistry, make sure that you can perform calculations, right? And most of the calculations is data specific to electrochemistry would maybe involve the E theta of the cell or the EMF, okay? These are some of the aspects of the calculations. In most cases, it's 3-4 marks, but also let's not rule out the possibility of stoichiometry, right? The stoichiometry, which has to do with the mole concept, can also be examined in this section of the chemistry paper, right? So this also has to do with the formula sheet, okay? You need to copy the formula as it is given. We've also mentioned that there's no need for you to manipulate the formula. Copy the formula as it is. Take note of the subscripts. Very, very important. The examiner is very particular when it comes to that. So you need to copy it as it is given, okay? Now, the other component of electrochemistry is the standard reduction potentials. Why exactly are we saying reduction? Because all those reactions in table 4A and 4B are based on gaining of electrons. But remember, there is a double arrow. So in us trying to identify whether a substance undergoes oxidation or reduction, we need to make sure that we use a single arrow to show that it moves from left to right. In some cases, we have to reverse. So the skill around, the use of the standard reduction potential is the main issue as far as electrochemistry is concerned. Right, okay? Also, the components, which is the anode, okay, as well as the cathode in an electrochemical cell, be it galvanic or electrolytic. But what is common with both classes of electrochemical cells is that the anode has to do with oxidation, right? So if we talk oxidation versus reduction, these two are actually processes, okay? These are actually processes, so which are involved with each of those electrodes. Now, let's be in a position to distinguish between a process and a substance. Now, what do we mean by that? Let's make a particular example. When we talk of a reducing agent, we're actually referring to a substance that undergoes a process. The process will be oxidation. So the confusion between substance and process needs to be very clear. Oxidation, process; reducing agent, substance, consent. So that link is very, very crucial, okay? Now, in writing half reactions, we have briefly touched on this. Say, for argument's sake, you are writing an equation that involves zinc losing electrons. It's going to be Zn, okay? That's an atom of zinc, okay? To give us Zn2+, that goes into solution, okay, plus 2 electrons. Right. Now, pay careful attention. The single arrow suggests that the zinc atom loses to give us Zn2+. Now, if you look at this half reaction, we are saying that zinc is the actual substance. Zinc atom is the actual substance that loses. So zinc atom is a reducing agent. So the examiner would maybe say, for argument's sake, identify the reducing agent in this half reaction. So Zn2+ is an ion of zinc, yet Zn is an atom of zinc. So what loses is the atom of zinc to give us at the end or to yield a zinc ion. So if we say zinc in general, we're not so sure whether we're referring to the atom or the ion altogether. So we need to be very specific and pay careful attention to the single arrow that points in one direction. All right? Now, the cell notation, we usually call it the ABC notation, okay? This is just for you to remember. It's as easy as ABC. Remember, we said these are easy mark. So A will be your anode, for argument's sake. So what happens in the anode? We have got, let's say, zinc atom losing to give us zinc ions, okay? And then the B, obviously, would be for the salt bridge. And then C will stand for your cathode. Let's say maybe you've got the zinc, the common zinc copper cell. Then we've got the copper ion, okay, for argument's sake, giving us copper atoms, okay? Just to correct that, this gives us the copper atoms, okay? So the atoms of copper is what is actually formed instead of the copper ions. Then we are saying that these copper ions are actually the oxidizing agent, not the copper atoms. Because what gains, according to the reaction, will be the copper 2 plus ion, okay, plus 2 electrons to give us copper metal, right? So the copper ion is the oxidizing agent, whereas the zinc atom is the reducing agent. So it's very important for us to actually understand that. Now, let's look at a typical example of, a galvanic cell, and maybe discuss some of the key points that you need to remember as you approach this question. Now, this is a typical exam question that, you can consider as an example. Now, it talks about, consider the cell below which operates under standard conditions. So as part of our strategy, we must underline the key terms or keywords. Remember, standard conditions, there's 3 of them, okay? But not all of them are always applicable. It depends on the type of electrochemical cell, galvanic cell that is given. So in this case, as you can see, there are no gaseous substances involved. So the 2 conditions that will be relevant for this one is the temperature, okay? It's the temperature of, 25 degrees Celsius, which is 298 kelvins, okay, as well as the concentration of the electrolyte of 1 mole per cubic decimeter, right? 1 mole per cubic decimeter, right? Okay, so very important that not all standard conditions are applicable. Carefully consider the uniqueness of the scenario that is given to you, and then decide as to which one is applicable. So we are given the net cell reaction in this case. So the net cell reaction essentially does not involve the spectator ions. So it's actually the substances or the species that are involved in the electron transfer. Some by losing, some by gaining. As a result, effectively, we've got a transfer, which is a redox reaction. All right, now let's look at the first question. It says, what energy conversion takes place? So the key thing in this question is about the energy transformation, okay? Remember, energy cannot be created or destroyed as we know it. It should be, converted from one form to another. So we recognize that this is a galvanic cell, right? So being a galvanic or a voltaic cell, we know that if this cell is set up under the standard conditions that we have mentioned in the previous slide, we know that the chemical reaction will take place, resulting in the transfer of energy of electrons from the anode to the cathode. As a result, we get electrical energy. So this question would usually maybe be 1 or 2 marks at most. So it's either you know or you don't. We know that in this case, under standard condition, this is spontaneous. So the implication of the spontaneous nature of this electrochemical cell suggests that this reaction will, if set up like this, a chemical energy will be transformed to electrical energy. So this is a basic kind of a problem. Okay, now let's look at a scenario of saying, okay, you are given 2 electrochemical cells. We spoke about the table for showing differences and similarities. Now, by looking at the second cell that we have at the bottom here, we know that this cell is an electrolytic cell. But what actually justifies that, that choice is because we can see that this is there is an energy source, okay, which speaks to the energy transfer that is involved in cell. Let's call maybe this one electrochemical cell B. Let's call this one electrochemical cell A. So we know that A is a galvanic cell or a voltaic cell because of the obvious thing. We see the salt bridge there, okay? And we know that this one is also set up under standard conditions. But most of these electrolytic cells, let's remember that they are used actually in application. So like in this case, this has to do with electroplating, okay? Which is the coating, okay? Now, there are a lot of implications as far as, electroplating, in real life. So when we talk applications, we'll refer to the 5 very important applications of electrolytic cells. So this can be easily summarized in the form of a table, okay? Right. And then the question B says, state the standard condition for this cell. Okay. Now we have recognized and appreciated that this is a galvanic cell. And we have also said, okay, seeing that gases are not involved, obviously we would make mention of the temperature, okay, condition, as well as the concentration. All right. Okay, those are the two that are relevant in this case. So emphasis is on this case, or this electrochemical cell, right? So that's temperature then. Okay, but also go on to state 298 kelvins and then 1 mole per cubic decimeter, right? So these are basic recall type of problems, all right? Okay, moving along, which electrode, okay, anode, is the anode iron or magnesium, right? Guys, in this case, you may even refer to the standard reduction potential table, but fortunately enough, you do not have to do this in this case. Why? Because we are given the net cell reaction. So that's the net reaction, okay, which takes place in this electrochemical cell. Now, by looking at the oxidation numbers of each of these substances involved, we are immediately able to tell, oh, okay, iron Fe3+ to give us iron metal, okay? What should have happened to iron, okay? We are simply saying that iron actually gained electrons. So if iron gained, it means we'll say +3 electrons, okay? 1 arrow to give us iron. So that's our oxidation half reaction, okay? So if this is our oxidation half reaction, again from the net reaction, we are able to extract the reduction half reaction, which is magnesium. There we have magnesium, okay, to give us magnesium 2+, okay, plus 2 electrons. So that's our reduction half reaction, okay. So now we are actually working backwards from the net reaction to the half reactions. So if we put these half reactions together, we actually get the very same overall cell reaction. So the use of the standard reduction potential is very, very important. So we have already identified the reactions in the previous slide, okay, by using the balanced equation of the reaction in that case. All right, okay? And then having referred to the standard reduction potential table, it's a very, very important tool in the sense that it allows us to actually, decide as to which substance is a stronger reducing agent or a stronger oxidizing agent. So if you carefully look at this extra, it's just a portion of the standard reduction potential table 4B, which is actually the same as 4A, just that it's in reverse order. If you look at the arrows on the left-hand side, in this case, most negative reduction potential is the weakest oxidizing agent, okay? Then the opposite would be that the most positive reduction potential is the strongest oxidizing agent. So what is important is to understand that an oxidizing agent undergoes reduction, and the opposite is true for a reducing agent. So familiarize yourself with the standard reduction potential tables, okay? Now, having said that, it's also important that you stick to a particular, table, be it 4A or 4B, whichever is user-friendly for you. But they actually communicate the same thing. It's the same sequence of reduction potential, but in opposite, starting with the positive to the negative. So we can use that to decide whether a particular substance undergoes a process of oxidation or reduction. Having said that, we'll look at more typical examples. Over to you, Loni.
Thank you so much, Themba. Guys, I hope you're still enjoying the show and you're getting a lot of information to help you with your upcoming exam. Don't forget to hit us up with your comments or questions on our social media platforms, and we'll assist you as best as we can. For now, we're going to take a short break, and we'll see you straight after this. Welcome back from the break, Matrix. We are still busy with your exam guide, so I'm not going to waste any more time. I'm going to take it straight to Themba.
Okay, Matrix, in our third and final segment of this session, we shall focus our attention on the applications of electrochemical cells, which means we must remember that there are 5 applications, and each one of them is important in industry, you know. So you must also realize that this has got, you know, real-life applications, okay? And this has nothing to do with the standard conditions. So the first one is actually based on the electrolysis of molten salts, an example of which is copper chloride. Chemical formula, something that we discussed in our opening segment. We said chemical formula from grade 10 is very important. And this is molten. Molten, it's not dissolved in water. It's heated until it melts. And then, obviously, the ions that are present in that substance is something that we need to be clear of. Then we've got copper 2 plus and the chloride ions. Now, the understanding of these chemical formula has far-reaching implication in as far as, you know, the half reactions that take place in the electrochemical cell. So the periodic table, the standard reduction potential, is some of the tools that will be given in the exam. It's something that we need to be familiar. It can also help us in terms of the chemical formula, right? The second one is based on the electrolysis of sodium chloride, okay? But this sodium chloride is a solution. Pay attention to that. If we talk of a solution, in this case, it's going to be Na, okay, Cl. But this is an aqueous solution, which has been, a substance has been dissolved in water. And then again, the ion or the chemical composition of this substance, which is the Na plus, the sodium cation, okay, and the chloride anion, which are present, okay? Because remember, as far as electrolysis, we are talking about what is common about these 2 applications is that, you know, electrical energy is converted to chemical energy. So we're using electrical energy for these redox reactions to actually take place, right? Moving on to the example of the electrolysis of sodium chloride. Now remember, the chemical name of sodium chloride, it will be referred to as brine. This is a concentrated solution of sodium chloride, okay? So that's the alternative name that will be used. So a diaphragm cell is one of the 3 types of electrolytic cells that can be used in the electrolysis of sodium chloride solution. But what is important here is that the sodium chloride, which contains the 2 ions, the chloride as well as, you know, the sodium cation, are pumped into that chamber there, and because of the ions, then we get the chlorine gas being formed, and then now the diaphragm is made up of asbestos, of which this has got far-reaching implications in terms of you know, environmental impact. However, one of the key aspects of this electrochemical cell is that now in the cathode compartment there is both sodium ions, because the asbestos membrane is actually porous. It allows it's a cationic membrane, so it allows the sodium ions to pass through from the anode to the cathode, while there are also water molecules. Now, by inspection, you'll be tempted to say that the sodium will undergo reduction. However, if you refer to the standard reduction potential table, you'd realize that water is a stronger oxidizing agent than the sodium cation. As a result, we get hydrogen gas formed from that compartment in the cathode. But what also remains true is that you know, this type of an electrochemical cell for the electrolysis of sodium chloride is less common because it has a lot to do with the percentage purity of the sodium hydroxide, which is the caustic soda. Okay, so take note of that name, caustic soda, which refers to sodium hydroxide. Right. Now, moving on to the other electrochemical cells, because we mentioned 5 of them in terms of application. We have got the electroplating. Sometimes we refer to electroplating as coating. So you'd see that in real life, you know, some of the materials that have got certain physical and chemical properties are used to improve the appearance, to preserve, to add value to a material. So remember that the object that needs to be electroplated is always on the cathode. But what's so special about the cathode? Remember that the reduction half reaction takes place, okay? So these are straightforward kind of, half reactions that you need to remember. And then the other electrochemical cell is electrorefining. This has to do with purification. Remember, most of these substances, they are actually, they occur in ores. Ores is in raw materials. So they need to be processed to actually obtain, say for argument's sake, pure copper. So in electrorefining, we are actually removing impurities. So in both cases, electroplating and electrorefining, copper being an example, there are redox reactions that take place, and we'll go on to break them down into oxidation as well as reduction. Now, aluminium is one of the most important elements, in everyday life. You think of it in terms of the physical as well as the chemical properties of aluminium. It's light, low density. That's why it's used to make aircraft bodies. It's also corrosion resistant. So there's a huge demand of aluminium. So aluminium is extracted from a raw material that is called bauxite. So this bauxite, remember, grade 12, is Al2O3, okay? This is the ore which contains aluminium. So electrolysis, the electrolytic cell that is used in the extraction of aluminium will ensure that we extract this aluminium from this ore, right? Okay, and then here is a typical example of, of an electrochemical cell which is electrolytic, okay? But in this case, it says a metallic object, okay, to be plated with copper. Now, I'm going to underline that part of the question, or of the statement, rather, to say we want to plate or to cover a certain material with copper. But now let's think about the properties of copper. Copper is used, in plumbing, it can withstand a lot of heat, and it is corrosion resistant. So there's a huge demand for copper. So as a result, we want to cover this metallic object with copper. Now the power source suggests to us that yes, this is indeed an electrolytic cell, okay? Now this is classification. That's where it all starts. So these are the components or some of the structural differences that exist between electrolytic and galvanic cells, right? So it also speaks to the energy transfer or energy conversion rather, okay? It also talks to the energy conversion involved, okay? Because these are typically non-spontaneous because they're not set up under standard conditions, okay? But also realize that the electrolyte, so if you also understand that there's a lot of terminology in electrochemistry, and it's either we know these terms or we don't. So let's go back and revise the differences between electrolyte, electrolysis, electrode, the list goes on. So during this time, as we do the last push, as we prepare for the exam, let's get the language right, because that's what it's all about. And it is the legal detail that makes all the difference in science, right? Okay? All right, now the first question in this example says, identify which electrode will be the anode. Now, the key thing is anode. Anode is concerned with which half reaction. It has to do with oxidation, right? So again, understand that oxidation involves loss of electrons, okay? Okay, so if we lose electron, if a substance loses electron, then it has underwent oxidation. But so oxidation is a process, right? So if oxidation is a process, the substance that is involved is actually a reducing agent. So that's part of the language as we go on to emphasize that. So we need to identify the anode. So now the copper metal must actually undergo oxidation in this case, because at the end, on the surface of this metallic object, we need to have copper ions being reduced. So that's the Cu metal undergoing oxidation, okay? Then once that happens, the same copper ions which are present in this electrolyte Because remember, in this electrolyte, we've got Cu2 plus, as well as we also have the sulfate ion, SO4 2 minus. But remember, this one becomes a spectator because it's not in any way involved in the transfer of electrons. So this question wanted us to identify the substance that will actually be the electrode, okay, the anode rather, okay? Now, the terminal to which the object must be connected. So remember, the positive, the polarity of the terminals of the power source has also implications, or it indicates whether that is an anode or a cathode. So on the surface of the metallic object, this half reaction must take place. Cu2 plus 2 electrons, okay, to give us what? Copper metal, okay? So on the surface of this, we must have, actually this takes place again, we must identify the electrode concerned, it is the cathode, all right? So go back and revise again in terms of the electrolytic cells, which one is positive, which one is negative, and which of the processes are actually concerned with that, okay? Because basically this has to do with remembering a lot of stuff. There's not so much of thinking and application, you know. State whether the copper ions are oxidized or reduced, okay? Now, we need to first of all identify whether the copper ions are we talking about the copper ions that are in the solution or the electrolyte. Definitely, that electrolyte contains Cu2 plus, while that metal again undergoes the oxidation because we said it is a reducing agent, okay? So obviously, the copper ions that go into solution are going to be reduced, okay, to give us that copper metal, which this takes place on the surface of the metallic object. Right. Now, there's quite a lot that we can extract from this, but beyond that, it's also important to, you know, go back, revise the terminology, examination guideline. But in closing, then let's look at some of the most important tips as far as generic, you know, strategies to exam approach. Always start with the questions that you can answer so that you can effectively manage time. So time management, very, very important, okay? There's no sequence of answering the questions. Those that you can get the most marks from, I think you can start with them so that you can boost your confidence and also deal with the anxiety that comes with the exam, okay? Collect the data. If the question is given, read carefully and analyze what is given, what is it that we are looking for, and beyond that, we need to pay careful attention to action verbs: define, list, state, explain. So in calculations, finally, we need to show all your workings because marks are credited for the steps that you took instead of just the final answer. So beyond that, we need to also try to, you know, cover as much aspects of the exam prep that, because this is an individual thing. What can be a weak point for me may not be for the same person. So as a result of that, focus on those aspects that you need more attention on. Okay, because of time constraints, I think we would only confine our discussion to this part of the exam prep. Over to you, Lonnie.
Matrix, thank you so much for tuning in and thank you for engaging with us on our social media platforms. A big congratulations once again to all of our winners who will be announced on the Facebook page. Just stay tuned after the show to check all of those details. You can catch more revision shows, guys. All you need to do is check out the schedule on www.wozamatrix.co.za. But from me, Looney, Nicolene, and Timba, thank you and goodbye.